Yes, I am Savraj from the Sri Venkateswara College of Engineering, and today we are going to discuss the topic optimal binary search trees in C. This is a very important topic in DSA. So we are going to discuss today binary search trees overview. First of all, we are going to introduce. Then after we cover the key properties of binary search trees, then left subtrees condition, right subtrees condition, efficient operations and applications of binary search trees, and memory management and the searching algorithms. These things we are going to learn in this video. So, understanding optimal binary search trees. Search time efficiency. An optimal search binary search tree minimize the average search time and making data retrieval faster and more efficient. Balance structure. Unlike regular binary search tree, optimal BSTS maintain the balance structure and reducing the tree's depth and the enhancing performance. Minimized expected search cost. Optimal BSTS designed to minimize the accepted cost of each operations and thus improving all users experience. Comparison with the regular trees. The regular binary search trees can become unbalanced and leading to the efficient search operations and increased time complexity. Node distribution. Optimal binary search trees ensures even duration of distribution of nodes and allowing for the more informed search time across the various operations. Key characteristics of the optimal binary search trees. There is cost of searching, depth of the tree and height of the tree and the balance of the tree. So dynamic program for the optimal BSTS. It means binary search trees. Dynamic programming explained a method for solving complex problem by the breaking them into the simpler subproblems. Second, dynamic programming is particularly useful in construction optimal binary search trees. Define cost table. Create a table to store the cost of optimal binary search trees for a different subset of keys. Re- Recursive cost calculation. Recursively calculate the cost of each subset of the keys using the previously stored values, and the building optimal trees. Construction of optimal tree search based on the calculated cost from the table. Understanding the cost of binary search tree. Search cost average versus the worst case. Formula for a cost calculation. Formula for a cost calculation using the formula CG is equals to the summation of pi and die, and where pi is a probability and excessive accessing key I. Key definitions. Understanding key terms like the probability p and depth d, the crucial accurate cost calculation, and the implications of tree structure. Constructing and the optimal binary search tree. Identify new and probabilities, dynamic programming approach, cost table construction, backtracking for optimal structure, and the balanced tree outcomes. Optimal binary search tree construction. Firstly, root nodes. The root of the optimal binary search tree is 20, chosen for the minimal expected cost. Then left child nodes 10 are the left child is the root and the lower axis probability. Right side 30 nodes of the right child of the root indicating higher access probability. Access probability for 10 is zero point 0.2, influencing the position of the binary search tree. and the access probability for 20. Node has 20. Node 20 has the highest access probability, 0.5, making this the optimal route. And access probability for 30. Access probability for nodes 30 is equals to 0.3, and which is lower than the root. And total expected cost calculation. The total expected cost calculation based on the probability of trees structure and the binomial BST structures and the binomial optimal BST structure with the 20 at the top and branching 10 to 30. Implementing optimal BSTs in C. Node structure definition, core function delete, core function insert, and the core function search. Construction of an optimal binary search tree using the programming of efficiency. Input data, keys and their corresponding frequency are the inputted to the function. Dynamic programming table, a table is constructed to store the optimal structure solution for keys. Cost calculation, calculated for the each subtree to the determine optical tree structure. The final binomial BST construction based on the cost calculation. The construction binomial BST is the return there, the caller function is the return statement. Performance analysis of the optimal BSTs, the complexity overview, insertion of deletion complexity, searching efficiency and comparison with the balance trees, and the graphically performance and representations. Benefit of the binary search trees: efficient searching, memory utilization, and the idea uses cases. So the limitation of optimal BSTs and the key challenges in optical binary search trees: complexity of implementation, challenges in build balancing, and overhead of construction timing. Application of the optimal binary search trees algorithms. Optimal binary search trees enhance the algorithm like human coding, Huffman coding, and leading to the efficient data comprehensive databases. They provided the efficient indexing mechanism and significantly improved data retrievals times in the database. And software engineering. In software engineering, these trees helps organize data optimally in memory and enhancing performances. Key takes away on the optimal binary search trees: improve algorithm efficiency, dynamic programming approach, and the future research directions. So log the power of optimal binary search trees. Join our channel to know more about the topics of DSA and getting clear concept. So thanks for watching our video and support. Please do the like and subscribe to the channel, and please hit the bell icon for getting all new updates on your notification first.